So, good afternoon, everybody. I'm hoping here in Lausanne you've all had a wonderful conference so far. I've learned things. I've had some great. Woo! Oh, there's a little. Woo. Don't overdo it now, everybody. Woo. I hope you've all had a great time so far. I know I have. I was last here 7 years ago. I realised we had the 10-year conference here in Lausanne. I'd forgotten. How sad's that? So, where are we? Let's talk about LLM4S and GenAI in general. This all started in January when Kannupriya and I were at a hackathon. We were in London, we're at a hackathon, and I was bemoaning the fact that I was doing a load of AI work, but I was doing it in Python. And it made me sad. And Kannu then said to me, well, why don't you fix it? So I literally started a GitHub repo with nothing in it and started hacking away. And this is where we're up to 6 months later. Hooray! So we think Scala is the right place and has a significant opportunity to be the right tooling for building cool apps. So we started building a batteries included framework to meet the needs of the users. So rather than sort of giving you lists of things that we've done, we are going to start by giving you a demo. Hi, everybody. During our Scala Days talk about LLM4S, one of the key components was to show you a demo of all the features and all the cool things we've been building. The demo did not go as planned. Without Wi-Fi, hosted LLMs in other countries just don't work. It's weird. I don't know how that happens. So we've had the chance to re-record the demo section of our talk to show you the things we wanted to show you then. So when you watch the rest of the talk afterwards, hopefully a lot more will make sense and you can see what we've actually been doing. So let's jump straight in. So I'm hoping at least some of the audience that are watching the video this time have played one of those old style text adventure games. One of the early ones was a game called Zork, hence our new game name. So text adventure games, you give commands, you go north, you go south, you pick up the screwdriver, you take actions, and you're basically puzzle solving. And these were very popular back when I was younger. So let's start and play and you can see what's going on. So we don't have any adventures defined. These are just little icons to tell us what of the AI features we've enabled, and we will talk about those individually when we get to them. So let's start a new adventure. Kannu, I need your help. What kind of adventure do you want today?
We got a lot of adventure themes, which is really nice. I would choose Space Frontier.
Space Frontier, excellent choice. Rockets and cool stuff. Right, second choice. What kind of graphic style do you want?
Ah, visual styles.
Yeah.
Comic?
Comic graphic novel. Oh, bold choice. So let's do it. Now, this bit takes a few moments. What's actually happening is in the original games, you would load the game from tape and it would have all the content pre-built by the author. What we have here is the LLM. We've actually asked generative AI to not just run the adventure for us and act as a dungeon master, but actually generate an entire new adventure based on the themes we've picked. It's a space adventure, and you'll see where the graphic style comes back in a moment. So it's thinking away. It does take a little bit of time because it does quite a lot of work. It's writing and designing an entire adventure. So this is all running via LLM4S. This is basically our first demo application. So we've built it to showcase what we've been doing. And this is built by us, by volunteers, and by some of our GSOC students. And we'll talk more about those guys a little later. So it's a bit like one of those Windows bars that says it's nearly done all the time. It is nearly done, promise. So it'll tick away. Come on, come on. I'm excited. I want to get on with the adventure.
Okay, so you mean it's calling Zork is calling LLM4S in the background. to creating this new adventure,
Yes.
right?
We give stellar cartographer. Hey, the adventures. We can continue talking about that because it does take a few moments to start the first prompt. Yes. So Zork is a Scala application which we will share on GitHub that calls the LLM4S library, which is
Blue-white light from the main display casts
Wow.
shifting shadows across banks of humming instruments. Warning indicators blink amber on several panels, their soft chimes creating an anxious symphony. A brass navigation compass sits prominently on the central console, its needle spinning wildly. To the north, a sealed airlock door bears the words Observation Deck in faded stencil. The cartography lab lies through an open archway to the east, while maintenance shafts descend into darkness below.
so. I'm probably going to shut this music off in a moment because it's quite hard to talk over it. And it's actually quite a short loop if you listen carefully. So let me just shut the music off. But before, I'm going to talk about the music a little bit. When the LLM, what we're using is who here, I'm hoping a few people here have played Dungeons and Dragons. So in Dungeons and Dragons, instead of having, in Zork, it's a static adventure. It's hard coded into the application in the original Zork game. Here, it's dynamically generated, and we're basically using the LLM as our dungeon master. So it acts as the person that knows what the secrets are, and it's going to tell us about the locations, give us information, and allow us to do things. One of the things we asked it to do, we asked it to do two things. Generative AI isn't just LLMs. It's also things like image generation, music generation, speech to text, text to speech, all of these different tools. So we put them all in because LM4S supports them all. So the first thing you do, when we ask the LM to generate a scene, we also ask it to generate a music prompt and an image prompt. And we send those off to one of the various image generations, one of the music generation libraries, and they would generate music and sound for the scene. We can turn them on and off, as you can see. But here we go. So we've got a nice funky image in an appropriate style. Although I think, to me, noir is actually black and white. So maybe we need to adjust our prompts just a little bit. But hey, it's a cool image. So we're here. We're in this room. There's a compass. There's a airlock. What do you want to do, Kannu?
I would tell it to go north.
Go north. Well, let's try. Actually, I'm going to tell it to go north. One of the hidden features in here is this. Go north. Hey. So again, another generative AI tool, speech recognition. So speech to text.
The airlock door is sealed shut, its heavy metal surface cold to the touch. Red warning lights frame the entrance, and you can hear the faint hum of the locking mechanism. You'll need to find a way to unseal it before you can access the observation deck.
Okay, so like any good DM, it's like, you can't go that way. Look, it's a big sealed door. So maybe we should do something else. So let's, what do we do in adventure games? Well, we pick things up. What's in here? So actually, let's look at our inventory right now. What have we got?
I see we got some help around there on the screen.
You aren't carrying anything.
Oh no, we're not carrying anything. So I got some help with these buttons up here, can you?
Yeah, I see some suggestions also coming to.
Yeah, so like most text adventure games, we do actually tend to list what exits are available. But it says north is sealed, so we could go east to the cartography laboratory, down the maintenance shafts, descending into the darkness. So, but before we do that, I'm going to, if we look up here, it says, oh look, there is a compass. So let's actually examine the compass.
Mm-hmm. Ah,
Yeah, it might take a few
The
seconds.
brass navigation compass is an elegant instrument, its polished surface reflecting the control room's amber warning lights. The needle spins erratically, unable to find magnetic north in the depths of space. Strange markings around the rim suggest it might be more than a simple directional tool. Perhaps it's designed for stellar navigation. The compass appears to be removable from its mounting.
Now, if you've ever played the text adventure game, there are generally pretty good hints in the text. Oh, it might be useful for solar navigation, and it's removable. Let's take it then. Now, I'm going to turn off the voice narration just to make our lives a little quicker for now. But voice narration is, again, another one of the generative tools, text to speech and speech to text, so the inverse of each other. So we've carefully taken the compass, and we can carry on. Which way do you want to go now, Kanu? The north is blocked by a big sealed door with flashing lights, so let's not go that way. Do you
I
want to go?
like I like that we can type what we want to do and we can speak what we want to do as well.
Mm-hmm.
So I think we have given voice instructions so far. Let's
Yeah.
give some commands, like type some commands and try to go east,
Let's
maybe.
go. Okay, let's go east. Yeah, let's do it. Oh, we're clearly in the cartography laboratory. Look, there's maps everywhere. Oh, with a cold coffee mug. Let's I want to take the coffee mug. Now, if you've ever played some of the old games, what you find is actually the things you can do are very limited. Oh, it was recent. Great. So we've generated a new image because it's a new room that's related to the room. The thing is, we can actually do anything we like because there's intelligence behind the scenes. We can lie down. Oh, that's not fair. The dungeon master says, come on, we're playing a game. Let's not lie down. But if you've ever played Zork or one of those games, you'll find that if you do something, it doesn't go through. I don't understand that. And that's it, right? There is no flexibility. And we haven't found any characters in this game so far. But if you did, you can actually have conversations with them because the LM will generate the responses. Now, I've also found for my taste, the descriptions are a little too verbose. So maybe we'll tune that in the next iteration. So the key thing I want you to take away from this demo is really there's multiple things going on here. Starting with simple generation, right? We've got text to speech, we've got speech to text, we've got image generation from a prompt, we've got music generation from a prompt. And then behind the scenes, we've got two other things going on. The first is we've got an agent. Now, the LLM is running in a loop. It takes our instruction, it does something. It might do other things. And one of the things it does do is the inventory is managed as a tool, which means instead of it trying to remember in the prompt what's going on, it remembers what's in the inventory by storing it in a tool that it can call. So it has tools like list inventory, take item, drop item. All those things allow us to manipulate those tools. And one of the biggest ways of making LLMs do useful work is giving them the ability to do other things, like your modern code generation tools. They're reading and writing files, they're compiling things, they're taking actions, and giving an LLM the ability to an action, read the result and take more actions is the whole mechanism behind there's really modern tools such as the whole agentic movement now. And that really empowers them to do much more things. Early ones were like, if you remember ChatGPT in the early days, you gave it a prompt, it gave you a response. That was it. Now you can have entire conversations, it can do web searches, it can generate documents. All these things are tools that have been given to the LLM to make it work. The LLM4S framework supports all of these features and a bunch of others, which we will talk about. So there you go. That's a demo. And clearly, sometimes it doesn't work because if you look at the last message on the screen, it generated a prompt that was too long, which the code didn't handle and gave up. Hey, that's software, right? This is on my side rather than its side, though, so who am I to say? So there you go. So this is the end of the second version of the demo. Hopefully that's given you a much better insight into what LLM4S can do out of the box, and enjoy the rest of the talk. Anything you want to say in closing, Kanu?
Yeah, I think it's a very interesting game, and I would want everyone to give a try. So, we have a README page which has all the instructions to do this demo yourself. And yes, we are very proud of making this first application using LLM4S. And yes, let's dive into the main talk.
So the amazing demo you've just seen, let's peel back the curtain. We're using tools from LLM4S to do a lot of the features that I'm hoping you're going to get to see in the very near future. If not, come and see me afterwards, and I promise I'll show you something, because I'm quite pleased with it. The first thing is using the LLM as a dungeon master, which makes it really flexible. Instead of just being able to say, open door, north, south, pick up X, and it has to be exactly X. It might say, there is a shiny compass here, and you have to type in pick up shiny compass, which doesn't work. LLMs are great at this kind of textual understanding. So that's the first step. The second step is we can use an agentic loop, right? Basically, we're running the LLM in a loop. Each step is basically, we take some user input. This is like chat on ChatGPT. You can actually ask ChatGPT to give you an adventure. It's not very good. It's just running in a loop, taking your input, and updating its internal state. Agentic workflows are one of the key techniques of running modern LLM-based workflows. Tool calling. The LLM doesn't just use its own internal memory. Who used like the original ChatGPT? Yeah. Did you ever find it cut off? It didn't know stuff because the point at which it had been trained to, the point at which it was trained, 6 months or a year earlier, was the end of its knowledge. So you could ask it a question about modern things and it knew nothing about them. Tool calling, and RAG that we'll come back to, allow you to give the LLM tools to explore the world. Like, what time is it? An LLM cannot on its own answer what time it is. Right? It's just a model predicting the next word. It'll sound like it does, it'll guess, but without an actual tool, it can't use. Tool is basically allowing the LLM to make function calls. And those can be local in your application or remote with MCP. Beyond that, you've got other GenAI apps like speech-to-text, text-to-speech, image generation. All of these things, which are beautifully demonstrated in the app you can't see. One last try. Error, failed to start. Okay, I think there's a dead loss at this point. Oh. Right. But the point we're trying to make is really that everybody talks about building business applications for these things. I think there's a whole space for building other fun applications. But LLM4S in the last 6 months has gone from being an idea to a toy to a usable application. Right? You can do everything. You can do a lot of the things that you would do if you were using the tools in Python. So you can talk to multiple providers. You can talk to Anthropic or OpenAI or whoever you choose. It supports, I can't see my own slides now. Across Scala, we can do it. 2.13, Scala 3, all that stuff. Because we started, I started because I really cared about code generation. And it's really interesting to listen to Andre's talk earlier and some of the other talks about how to do that. So I created like a secure environment for it to run in. Error handling. We know Scala's great for that, right? This is what it's for, right? Doing code well. MCP support, allowing you to call. So these are all the basic toolkits now when you build an LLM app you're going to use. Agent frameworks are now the cool thing. Everything's going to be an agent. Everything's agents calling agents. They don't actually work very well at the moment, but it is the future apparently. Multimodal is quite key, allowing it to do, say, I took a picture of this thing, now do something with it. And RAG, we're going to come back to RAG as well. And then observability. When you're building production apps, you actually need some other things that aren't just oh, I'm able to call an LLM. I think LLMs have a huge issue with what I call the demo effect. It takes 10 minutes to build an LLM app, and you're like, it works, right? It translated this text. Who saw the Devin, the original Devin demo? Who saw the take apart of the original Devin demo? So what it turned out is they had a video of it generating code on the fly and doing great stuff. And it turned out they had cut the video, changed the prompt, done stuff to make it look like it was a really smart, really fast agent. And it wasn't at the time. And actually what's really weird is the LLMs are caught up. Right? The stuff they were doing then, it can actually do. So I wanted to briefly talk about agents. So this is one of the key concepts in LLMs now and using generative AI, which is it's not just about the original, prompt response. The whole thing, software development agents, all the tools, including like ChatGPT and if you're using Claude AI on the website, are all about loops now and doing stuff and observing results. So to make them really useful, they all have this built in. So Claude will actually go and search the web for you, right? Or call an MCP server or do something other task. And it's really an action observation loop, right? So the LLM can choose to do one of two. It's all just text. It's like writing instructions for a junior, right? At the end, you can ask one of two things. You can say, call one of the tools I've given you, or give me an answer. So if you don't know the answer, what time is it? Oh, I don't know what time it is. What tools do I have? Oh, I have a clock function. So it's going to respond back. Instead of giving you an answer, it's going to ask to call the clock function, get the result from that. And basically, that's another text input. So now the prompt has the original question, the call that it made, the response from that call, and now it goes, now what do you want to do? And it goes, oh, well, now I've got the time, I can answer the question. And it turns out that simple loop is really powerful because that loop can be, please write me some code. And it says, oh, I can look at the code that's currently there, grep, cat. I can write code, I can run the compiler, and I can observe the result, which is just text again. And I go, oh, it didn't compile because of this compilation error. Feed it back in, what action are you going to take now? Exactly like if you were teaching someone to program, right? Write the code, look at what's there, write the code. Oh, it didn't compile, what do you do now? We go back to the code. Same thing. But this loop is a key to the whole modern ecosystem. So it's not just us. This is one of the wonderful things, and I completely blame Kannu for this, which is Kannu isn't just involved in this and got me started on this, but she's involved with the Scala Center in running GSOC, the Google Summer of Code. And we've had 4 GSOC students working this summer on features. And in fact, most of the major features, which I was going to demonstrate to you, are written by them. So we are going to quickly go through those students and what they've been working on and how that fits into the bigger picture. I think Kannu's actually been with the Scala Center for like 3 years now, 3 or 4 years now in this program? Yeah. Yes. And the GSOC program at Scala Center has 14 students this year. So GSOC fund those students to work for 3 months on open source projects. It's awesome. So let's look at some of our students. So this is Elvin. Elvin. Hey! So Elvan is a student, I think technically is still a student at EPFL, at least until the end of the week, when she's then off to Geneva to do her master's, which is awesome. But Elvan has implemented, when we say LLM4S, I can't even talk now, LLM4S supports MCP, it's all Elvan, including fixing up as they change the protocol. Literally, we merged the request, 2 days later they updated the protocol and a whole bunch of features. You know how it is, right? So I'm not going to cover MCP in detail, and the reason is there's been multiple talks today, and MCP has been mentioned multiple times. So MCP is simply a way, think about your program, as I say, LLMs can call tools. One of the things they can call is the problem is with those tools, they have to be built into your application. You say, here are the tools that are available, and it can call them. MCP is basically a dynamic way of plugging in features. MCP basically describes what function calls are available, what types they take, and what the function does. Right? And by adding that, you can now get, for example, you can get Claude to read your emails. Right? If you've got an MCP server that understands how to talk to Google, Google Mail, you can now connect those two things together. So, especially as the time, I'm going to, when we share the slides, there'll be some more technical information. All these slides were generated by the students, or the slides for the student part were created by the students. And I'm hoping that we can convince them to give talks about the pieces they've done on GSOC in the future. So watch out for those. They're going to be awesome. They've done some amazing stuff. So our second person is Gopi. Gopi has been implementing RAG. Who knows what RAG is? More people know what RAG is than have played Zork. That's very sad. Oh well. So to briefly cover RAG, and I know this has been mentioned as well, think about it this way. An LLM has a limited memory, right? The only memory an LLM has is stuff it's trained on, which costs millions of dollars and is really hard. Mainly it's really expensive. You need specialist hardware, you need millions of dollars, and you need a lot of time. Beyond that, you used to have this context problem. The moment they've trained you, there's nothing more. They don't know anything more about the real world. This is what tool calling and so on is about. RAG takes this further. Imagine what I do is I basically take Wikipedia, for example, and I chunk it into pieces. In those pieces, I what's called semantically embed them. I turn them into a number. The key is those numbers, if you have two pieces of text which are similar, the numbers will be similar. I take all those and I throw them into a database. So now when the user comes along, so that's the ingestion part. I basically ingest documents into my search index. When a user comes along with a query, I embed the query. And now what I do is I try and find documents that are similar to the query. Right? So if the user talked about GSOC or Scala or GSOC and Scala, right? The search should return documents that have those words in them. What I do is I then take those documents, and instead of, in the old days of Google, you typed in your Google search, and you did something similar to this and gave you back a bunch of documents, right? Now what does Google do? It takes those documents and says, well, actually, you don't necessarily want to go and visit all these sites. You're trying to work out how to write a for loop in Perl, right? Don't ask. What you actually want to do is get an answer. How do I write a for loop in Perl? So what you do is you give those documents to an LLM, and you say, given this knowledge, how do I do this thing? And it turns out this works surprisingly well. Right? You can provide real knowledge to your application just by effectively doing search. It's effectively running a Google search and getting someone to summarize the answers. But you can do it with your own knowledge. You can do it in all sorts of ways. And I can talk for hours about the examples of things we've done with this at work. So RAG is a really great thing. It's not quite finished yet. We've done the embedding part, and Gopi is working on the remainder. So I'm now going to hand over to Kannupriya, who's going to talk through the remaining two GSOC students and talk much more about the community and what else we've been doing. So over to you, Kannu.
Thank you, Rory. When people talk about GenAI, they generally mean LLMs, but the space is much wider than that. Multimodality is LLMs handling things other than text. We all know about this: image, video, speech, time series, both generation and comprehension. It all uses GenAI under the hood. Anshuman is a student in India
who has been working on multimodal generation for LLM4S. I love this picture. So these are the features which Anshuman has implemented. Image generation, both local and remote. Image comprehension, we haven't demoed that, but yeah, most of that. Text-to-speech with Tacotron 2 for natural, clear voices that work out of the box. And then speech-to-text with multiple backends, including lightweight offline CMU Sphinx and high-accuracy online options, such as Whisper 2. Tracing is a key part of writing stable, debuggable AI systems, tracking and recording the various LLM calls. Shubham, a third-year engineering student from India, has been implementing tracing with us. LLM4S toolkit supports tracing in 3 modes, depending on your use case. Firstly, full tracing to Langfuse and OpenTrace, both open and cloud-based services, which we will show next. Secondly, you can also run in local mode, which logs the tracing information out in a clear format to the console to debug smaller tasks. Lastly, if you don't want it, you can always turn it off, and it will have no impact on your execution. Langfuse is an open source and cloud solution for tracing, evals, prompt management, and metrics for GenAI. It helps debug and monitor your LLM applications. You can see the Langfuse UI on the left showing a trace of an execution. The right-hand side shows the component layers within the application for reference. These kind of tools are often missed during early prototypes, but are absolutely essential for long-term application development. So why Scala for AI? You already know this. Otherwise, you would be at some random Python conference. Let's talk through some of the key points. Type safety and functional programming. Scala's design gives us great errors and protections, acting as a guide, not a blocker, helping both humans, which we all know, but it also helps AI to iterate quickly and correctly. So the correctness of AI, it all goes to good error handling that Scala has been creating for us for so many years. The Java ecosystem. Scala runs on the JVM, giving us interoperability with Java, Kotlin, and others, unlocking Java's libraries and frameworks. Concurrency. Scala has great tools for managing concurrency, giving us easy parallelism. And performance. The JVM gives us speed on top of Scala's elegance. But Python has all the AI libraries. It's quick to write, maybe, but it also fails at runtime for stupid errors. Don't make the snake sad. So what you can build with LLM4S toolkit? Almost everything on this slide, and other pieces which are in progress right now. Some things remain to be completed, and it's not all polished, but it's not theoretical, it's usable. You can build real-world GenAI solutions with this toolkit right now.
And now the slides have stopped working as well. Hey! Ah.
At the end of the day, it's all about community. As they say, to go fast, go alone. To go far, go together. As we are coming to a close, I encourage you all to think about how Scala can enhance your AI development, think about what a type-safe AI ecosystem looks like, and how we can push the boundaries of AI with Scala. If interested in contributing, check out the LLM4S on GitHub, explore open issues, and join us in building a type-safe AI-powered Scala ecosystem. We welcome collaboration from AI engineers, Scala developers, and open source enthusiasts alike. If you enjoyed the talk, please consider starting the project on GitHub. I want to bring a spotlight to an initiative that's been a big help for the global community, DevR. Every Sunday, 8 a.m. UTC, you can do your own time zone conversions. So far, we have had participants from all over the world. We host an open interactive virtual session where we collaborate. So far, we have had discussions, reviewed issues, had knowledge shared, and mob coded on features. We support each other to learn and work together. Everything is covered, from Scala to AI techniques to bugs. Anybody can raise anything. It's a great way to learn from real-world experience, see problems being solved in real time, and collaborate on your blockers with the group. If you haven't joined yet, come along. You'll walk away with the practical solutions and a stronger understanding of the AI concepts. Join the movement, build the cool stuff. From a random rant, we have been amazed to watch the community grow. 100+ members. See new and old members of the Scala community adding to the tools and discussions and actively supporting everyone. What should a Scala-based AI system look like? Come and help us build it. You can scan the QR code to join our community. To finish, let me introduce ourselves a bit more formally. I'm Kannupriya, a backend software engineer for 10 years, most recently at Sky. I have been actively involved in the GSOC for several years, from mentoring to leading the initiative with Scala Center. I'm currently mentoring 5 student projects across LLM4S and Scala Decks. I have spoken many times around the world about open source contributions, community building, and the projects I'm involved in. My current work is about shaping how typed languages intersect with modern AI ecosystems. And now let me ask Rory to introduce himself.
Thank you, Kannu. So a bunch of you know me already. I've been in the Scala community a long time now, which is a wonderful place to be. I've realized I cannot find all the talks that I've given in the past about mainly, probably people are bored of me talking about tooling. Right? I'm a big believer in building cool tools, and this is exactly where this project started from. So what else do I do? I give tours of a windmill in Sussex. If you're ever in Sussex, come visit your windmill. I will show you around, and I can get as nerdy as you want. I know a scarily large amount about windmills. I'm into tool building. Come and talk to me. I've contributed to the compiler. I've contributed to the libraries. I'm a big performance nerd. I also study sword and other martial arts. I have a 14-year-old son, and yeah, and I've ended up at this weird intersection between programming, tooling, and AI for the past couple of years, and it's been awesome fun. Even if you don't use it commercially, my recommendation for AI is come and have play. You can build new things, and it's really fun. So, we both care. The reason this whole thing exists at all, including my bad demo, is that we both care about building both good software and good communities. I'm a big fan of mentoring students and bringing everybody up. Right? I love sharing knowledge. I love talking, you might have noticed. So, that's it. Let's build cool things together. We do have a few minutes. Well, we have quite a few minutes because the demo didn't work, and that was going to be a certain amount of time. So we have lots of time for questions. But I would say come and get involved. Come play.
Just a second.
It's not just me. It's not just me.
It's what? It does now. Okay, perfect.
Hey.
Does LLM4S support running models locally, for example, through itself or Olama or something similar?
No, but one of our contributors has promised he's going to implement it in the next couple of weeks.
Okay,
So,
nice.
or come do it.
Are you wrapping some existing vector database, or you made your own, or?
Actually no, we don't implement our own. The easiest way of doing vector databases, Postgres has a vector database mode, so you can just enable it in Postgres. I've used Azure Search Service, which is it's really good. They don't publicize it at all, but it's a really good, really well-built tool that supports all the toys. And there are many, there's Chroma, and there's like 3 or 4 other big ones. So, yes, we've re-implemented all the AI tooling, but I think implementing our own vector database would be foolish.
Excellent.
Okay. I wanted to ask, for your agentic workflows, are you building in an abstraction similar to like what LangChain and LangGraph do, or are you just simply letting people code loops and then wrapping them in some kind of sandbox environment before they are allowed to run the code? What's going on with that?
Closer to the first and second. The reason is you need to control what you want to do to make a nice API is when you want people to be able to say, here's a tool, now run this agentic loop with this list of tools, and be able to add tools and define tools really easily. So managing the loop, you can think of it as, you want to make that happen automatically. It reduces the number of errors, basically. So yeah, it's a toolkit for doing that, and the goal is, my goal with all software is to make it as simple and usable as possible. Avoid the sharp edges. Does that answer your question? Have I missed anything?
The second part was when it generates code, like if it generates, like, for example, some Python code, are you just executing that locally to the system, or are you sending that to get executed in the sandbox environment?
So we haven't implemented, there's actually 2 parts. So one of the reasons I got interested in this was actually code execution. The code execution is a bit underloved at the moment because we've been mentoring students and building out core features. But actually, that one all runs in a sandbox. So if you run Claude Code or some of the others, they just run on your desktop. They do try and protect the file system, but it's scary how much code is run in basically just on my console. Different discussion. One of the first things we actually built was a containerized execution environment. So it all runs, it's just your code that it's editing, and it can't escape the jail. Because I think that's really important, because I hate the idea of someone running R-open-RF on my server. It's normally me that does it.
So I have a question about the demo, which I'm sad that it didn't work, but I would love to see it some other time. But for me, the true difficulty in playing role-playing games is scheduling with your group. So I don't play much anymore, but I find there's a steady stream of people who want to try it out. And so usually what I end up doing now is running introductory games for people who want to try it out. And one thing I've found, which I wasn't expecting, is universally people's favorite minigame is seeing if they can exhaust the GM's patience by haggling over whether they're going to take the starting quest or not. And I was wondering if this is a game they can still play with your application, or do you find it responds like a human, or do you find it as serenely patient all the time?
That's a great question. I haven't pushed it that far. That's a really interesting question, because sometimes, anybody who's used an LM, sometimes they really do get a bit weird after a while, if you let them run. I think we should try that. So one of the things I'm going to do, apparently the code doesn't work, so I haven't finished it yet, but I'll get it working again, and we'll push it onto the GitHub repo, and you can tell me the results. But yeah, I suspect you can haggle with it for quite a long time. One of the most interesting things I found with it, when you see a character in the game, you can actually have a conversation with them, which you could never do in the original ones because they just didn't have the, you'd have to code up all that. But now you can just have, how are you today? And they'll answer, right? And it's slightly odd, right? It's that slightly, what's the term for uncanny valley thing? Okay. Oh. Oh, goodness.
Oh, that's fine.
Okay, I think no more questions. Thank you.
Cool.